let's start putting some of the pieces together. We've talked about work. We've talked about changes in energy. We've talked about kinetic energy specifically. We've talked about forces causing objects to experience a change in kinetic energy. Now we're going to put all those pieces together. And all those pieces come together in something called the work energy theorem, which very simply tells us that there is a relationship between the amount of work done and the change in energy that an object experiences. Now, we will get into different types of energy changes in the coming weeks. However, our focus primarily right now is on the relationship between kinetic energy and work. We know that the kinetic energy of an object can be changed by doing work on that object. We apply a force through a given displacement. It causes that object to gain energy, or it causes to lose energy. And there is an equation that we associate with this that says that the change in kinetic energy equals the work. But I do want us to be really careful with the language that we use here when we talk about this. We are talking about the fact that the net work, the total amount of work done on an object, is equal to its change in kinetic energy. Write that down. The net work done on an object is equal to its change in kinetic energy. This particular mathematical relationship, this one right here, K equals W, is what is referred to as the work energy theorem. And that's going to be the starting point for most of the work that we do in terms of solving problems involving changes in energy, work being done, and so on. This is our sort of our template, our equation that we're going to plug lots of things into. But again, if you haven't already made yourself a note, please make a note that this is the change in kinetic energy, not the kinetic energy at one moment in time, but the change that an object experiences because of a net work that is done. If you think back to the lawnmower problem that we worked with last week, where we could calculate the work done by all of the forces, an applied force, a normal force, a frictional force, a gravitational force, and then we calculated the net work that was done by adding up all of those works. That's what we're going to have to do again here. We want to calculate the net work by looking at a net force.